All right, Algebra 1B students, welcome to part 3 of section 11.3 on dividing two polynomials with the long division method. One more wrinkle to add into this today is dividing polynomials where there is a term missing, or there's a zero coefficient in the term. What I mean by that is this. If we are asked to divide q to the fourth plus q squared plus q minus 3 by q minus 1. If we look at this first polynomial, what I want you to notice is my exponents go 4 and then straight to 2. So I am missing q to the third, somewhere in between there. Missing q to the third. And if we want to divide these polynomials with the long division method, we need to have all of those exponents represented. Okay, we need a q to the fourth, we need a q to the third, we need a q squared, we need a q, and we need a number without a q at all. Okay, so we need everything. We need all of these exponents. So what we have to do is we have to turn this into q to the fourth plus 0 q to the third. We have to add in our own 0 q to the third there, which obviously is not really adding anything because it's 0 q to the third, so 0 times that is nothing. But we need that q to the third if we're going to do this division. Okay, and then we add q squared plus q minus 3. This is the polynomial that we really need to be dividing. So the problem needs to turn into this. Okay. I'm going to erase this now so we have room to put our answer. But now we're doing q to the fourth plus 0 q to the third minus q squared plus q minus 3, all divided by q minus 1. And just as a reminder, in front of all of these q's that don't have a number is a 1. Always keep that in mind. If there's not a number there, think of it as a 1. And remember, if there's a term missing or if there's an exponent missing, when we go 4, 3, 2, 1, 0 q's, you need to add that in there with a 0 coefficient. Okay? And now the process is the same as it was in our last video. Q times something has to get me here to q to the fourth. Well, that's q to the third, right? Q to the third times q will get me there to q to the fourth. And if I multiply then the q to the third here and here, I get q to the fourth minus 1 q to the third. Okay. And now what I'm doing is I'm taking this stuff in red and I am subtracting all of this from what I have before it. Okay, and that's why I put the q to the fourth right under the other q to the fourth, why I put the q to the third right under the other one, and so on and so on and so on. Okay. Now, q to the fourth minus q to the fourth is nothing. Those go away, which was the whole point of this. I wanted those to go away. And now I have 0 q to the third minus negative 1 q to the third. Minus negative 1 q to the third. Well, 0 minus negative 1 is like adding 1, so 0 plus 1 is 1 q to the third. Okay, now I'm at the point where I once again ask myself, okay, I have to get to 1 q to the third. What do I need to multiply q by to get 1 q to the third? And the answer is q squared. Because q squared times q will give me q to the third. And then, again, I need to bring down this minus 1 q squared from before. Need to bring that down. And now if I do q squared times q, and also times negative 1. Q squared times q is q to the third. That's what I wanted. Q squared times negative 1 is negative 1 q squared. And now if I subtract these, well, the q to the thirds go away. And negative 1 minus negative 1, that goes away as well. So I have nothing. 0 q squareds. And I will bring down the plus 1 q here. Okay, so one more time, 2 more times, I need to ask myself, what do I need to multiply q by to get to 0 q squared? Well, 0 q squared is 0, So I'm doing, okay, q times something gets me to 0. Well, obviously that's 0. Plus 0 q. Okay, and then I will distribute that again over to here to the q and to the -1, but timesing by 0, right? That's a 0. Timesing by 0 gives me zeros for both. Both of them are zeros. So this is 0q squared and 0q. Now I need to subtract these two. 0q squared minus 0q squared, those have been nothing the whole time. So they're not even there. Now I have 1q here, minus 0q is still 1q, and I'm going to bring down my -3. My -3. And now for the last time, I need to ask myself, okay, this q here, q times what is going to get me to 1q? Well, obviously it's 1. Q times 1 will give me 1q. So 1 is my question mark, and that's what goes up here in my answer. Plus 1. And then I'll do my distributive thing one more time, times the 1 by q, times it by a -1, and we will find our remainder. So I have 1q, and 1 times a -1 gives me -1. When I subtract, the 1q's go away, and I'm minusing all of this. -3 minus -1 minus -1 is like positive. So -3 plus a positive 1 gives me -2. Okay? So that now is my remainder. And remember, when we solve a division problem of this type, we multiply, or excuse me, we add our remainder on the end of our answer as a fraction over all this stuff we were dividing by in the first place. So my remainder is a -2. So after my plus 1, I'm going to put minus 2 divided by this stuff that I was dividing by originally. Q minus 1. Okay. Now let's summarize what all this means. I'm going to go back up here. Get rid of this. When I divide q to the 4th plus q squared plus q to the 1st minus 3, all of that divided by q minus 1, I had to add in a 0q to the 3rd because I was missing the 3 exponent there. So I had to add in a 0 term. 0q to the 3rd. Okay. The answer that I ended up coming out with is q to the 3rd plus q squared, and then I have a plus 0q. This I don't really need to write. It doesn't exist. It's not there. Q to the 3rd plus q squared plus 1 minus 2 over q minus 1. Obviously that a is not really there. Okay. There's my answer. I have to add in 0 terms if this is going to work out properly. Okay. Now, I would like you to try one on your own. And I have been very nice and already added in the 0 term for you. I'm asking you to take h to the 3rd, h cubed, minus 4h plus 12, and divide that by h plus 3. Now, in order to do this, we have to notice I am missing something to the 2nd power right there. I'm missing a term here. So I've added it in here, 0h squared. No h squareds are in my original equation, so I put a 0 term there, and now I can do my division process. So I would like you to take a look at this division process here. A little bit shorter than the last one, but not by much. But try to find the answer to this division problem, this quotient, now that we have added in the 0 term. Pause the video, take a look here at this problem, then come on back and I will show you what we should get. Okay, we should have it with h squared minus 3h plus 5 minus this remainder fraction 3 over h plus 3. The only thing that I think might be tricky is when we get here, this is negative 4h minus negative 9h. Minus negative 9h. So negative 4 plus 9, because we're minusing a negative gives us 5h. And that's where we're plus 5 comes from. If you have questions about anything in this process, please make a note to ask me in class tomorrow. But I do have one more thing that we need to talk about before this video is done. And that is the very, very important step of making sure that both of our polynomials are in standard form before we divide them. Okay, both polynomials need to be in standard form before we divide them. And remember, standard form means the highest exponent is on the left, the number without a variable is on the far right. So if you're given problems with the order mixed up, like negative 10x minus 1 plus 4x squared divided by negative 3 plus 2x, you'll notice that both of these polynomials in parentheses here are mixed up in their order. They are not in standard form. So we need to rewrite them so that they are. So in this first polynomial, I need to start with 4x squared because that is the highest exponent. Then obviously I will go to a minus 10x because there's still an x on that one. And then I'll end with a minus 1. And I'm dividing all of that by 2x because that has an x. And then a minus 3 because that one does not. Okay, so we need to rewrite things in standard form before we can divide. Otherwise, all of our numbers will get messed up, and things will not work out the way they're supposed to. So now that I have that division problem, now we have this, and we can do our division process. Okay? I would like you to try this one. It's just like we've been doing. There are no zero terms here, so this is just like what we did in our last video, now that we've reordered things. So pause the video one more time, take a look at this problem, then come on back, and I'll show you what we should get. We get 2x minus 2 minus 7 over 2x plus 3. Because at the end, we had negative 10x minus negative 6x. Negative 10x minus negative 6x, like adding 6x. So negative 10 plus 6 gets us to negative 4x. And then at the end, negative 1 minus 6 gets me to a negative 7. So that's where our negative 7 comes from. Negative 1 minus 6 is negative 7. If you have questions, please make a note to ask me in class tomorrow. Otherwise, that is all I have for you tonight. Have a wonderful night.